Here we are, lesson 6.6, geometric sequences. This is the last lesson that we are going to do in chapter 6. So we're going to identify geometric sequence and extend and graph a geometric sequence. All right, in a geometric sequence, the ratio between each pair of consecutive terms is the same. This ratio is called the common ratio. Each term is found by multiplying the previous term by a common ratio. All right, so this obviously plays very well into this chapter because we just got done with exponential functions, which, were not linear. Therefore, they didn't have the common difference, or they weren't the arithmetic sequence. Therefore, they had a common ratio. So that makes them kind of in the same family here. So, we would try to check and say, like, the first thing we're going to do is be identifying if it is geometric or arithmetic. And so, 1 plus 4 is 5, but then 5 plus 4 is not 25. So that makes, then we have to look for this ratio. All right, here we go. So decide whether it's arithmetic, geometric, or neither. So you want to first, like we're looking at, let's find the ratio between the consecutive terms. 1/2, 1/2, 1/2. All right, the ratios are the same, so the common ratio is 1/2. So that makes it a geometric sequence. I always just kind of like look at this and say, okay, well, I'd be subtracting 60, but subtracting 60 doesn't work. So then it's like dividing by 2, which then makes it multiplying by 1/2. So lots of different ways in which you can do this. So find the ratio between the two terms. So 6 divided by 2 is 3, and 11 divided by 6 is not 3, right? So there's no common ratio. So it's not geometric. Then find the difference. So if you take 6 minus 2, and you get 4, and 11 minus 6 is 5, and 17 minus 11 is 6, there's not even a common difference. So it's not arithmetic. So it is neither. All right, and we are on page 196 of your student journal. So determine whether the sequence is arithmetic, geometric, or neither. So again, like I said, I start to look to see first, okay, 1 to -4, or I can take this -4 divided by 1, right? And then I take 16 divided by -4, and then -64 divided by 16. And they all have a common ratio or common factor of -4. So from here to here is times -4. Okay, times this -4 and times -4. So it has a common ratio that would make it geometric. And to explain, we'd say the common ratio is -4, okay? So we can try the common ratio form, or we can try addition, to see if it's arithmetic, geometric, and if neither of those work, then it would be neither. So here we would, I would look at this and say, well, from 3 to 7 is going to be +4, right? And this is also +4, so here's our common difference. So that's going to make it arithmetic. Because of the common difference. All right. Here we go from 2 to 4, which is +2, but then this is not +2. So let's see, is 4 over 2 equal to 8 divided by 4? Yes. Is that equal to 32 divided by 4? So this simplifies to 2, this simplifies to 2, and this simplifies to, oops, sorry. Oops. 4. So since these are not equal, there is no common ratio. So there's no common ratio, there's no common difference. This is a classic case of neither. No common ratio, no common difference. All right, we're going to write the next 3 terms. So you have to find the common ratio. You can use a table to organize it, however you want to do it. Remember, we're talking positions: first position, second position, third position, fourth position. So the next three terms would be fifth, sixth, and seventh. And it looks like the common ratio is timesing by 2. So you would just take 24 times by 2, 48 times by 2, and 96 times by 2. Here, then we have these. Okay, so, and notice here that every time it goes from, it's like an on and off switch, right? With a positive, negative, positive, negative, positive, negative. Since we're working with a ratio here, multiplying by a negative has that power to, every other one's going to be positive or negative. So we know it's going to be a negative factor. And in this case, because it's getting smaller, we would know that it's probably a fraction. So here it looks like we're dividing by 4, dividing by 4, dividing by 4. Therefore, we take this -1, and we know it's negative, times this -1/4. That's how we write it as a ratio, dividing by 4. It's a unit fraction, -1/4. And we go ahead and calculate it. So let's go ahead and give this a try. Write the next 3 terms in this geometric sequence. So we need to know, what is the common ratio? Well, here, times 3 times 3 and times 3. So we'll have to take 189 times 3, and I got 567. That times 3 is 1,701, and that times 3 is 5,103. So these get very large very quickly. All right. So why don't you go ahead and work out number 8. Work out number 8. What are the next 3 terms? And I will go ahead to number 9. Number 9, here's one of those on-off switches, right? So we know that our ratio is going to be negative. So 5 to 10 is -2. -10 times a -2, right? And times -2. So the common ratio is times -2. So when you take -40 times -2, you get a positive 80. 80 times -2 is a -160. -160 times a -2 is a positive 320. Easy peasy, lemon squeezy. Here we go. All right, so we want to write the next 3 terms and then graph. So we're going to have to come up with the common ratio. So times 4 times 4 and times 4. So when we multiply times 4, we'll get, I wrote this down, 768. And then multiply by 4 again to get 3,072. And finally, 12,288. Now to graph these, let's see, we're gonna run out of space. I know that, but I'm gonna mark the X counting by 2,000. Well, not really, but I'm just gonna mark the evens. 4,000, 6,000, 8. As you can see, we need to be, and then 12,000 would be, all right. And then we're going to use this as positions. X is our positions: first position, second position, third in the sequence, fourth in the sequence, fifth, sixth, seventh, eighth, ninth. And this is our first, second, third, fourth. So we have fifth, sixth, and seventh. All right. So we would graph 1 and 3, literally the number 3. 2 and 12, way down here. Look how crazy this is. 3 and 48. 4 and 192. And then 5, we're finally getting close to this 1,000 mark. But, so obviously these numbers are way off in my graph. 6, now we're going to be up over the 3,000 mark right here. And then the 7 is way up in here, like by the 2,000 mark right there. All right, so it's like, and very large. Okay, whew. Looks very familiar, right? Because it's growing exponentially. Okay, in the same family as our exponential functions, but not quite the same. All right. Now we get to write the function. All right, here we go. So we've kind of been through this before with the arithmetic. I'm just going to take you right here. I'll let you take some time if you want to pause and explore this table. It's also in your textbook, which you can access online if you need to. But in this case, because of the number of times that is a factor, right? Like if the common ratio is 5, which it is, r is equal to 5. And if we're starting, first position, we're starting with 1. And then we could get, calculate the nth position. We could calculate the 50th number in this sequence if we needed to, just by using 50 in place of the n. But what's happening is you can see that it's, the exponent is going up by 1 every time, but this is, exponent of 3 and it's the 4th position. So remember, n is positional. That's why we have to subtract the 1. So this is the important formula that you'll want to write down and keep handy. And we will be using that to find several different things. So write an equation for the nth term of a geometric sequence, 2, 12, 72, 432, and then find the 10th. So a sub 1 is going to be the first term, right? That's 2. Then you look for the common ratio, which happens to be times 6. So there's 6. Here's where they fit into the equation. First term, and then r is our ratio, and then n minus 1. So when we want the 10th term, now n becomes equal to 10. So we have 6 to the 9th power, and then that times 2. Remember, so we want to take 10 minus 1, which is 9, 6 raised to the 9th power, then take that times 2. So don't forget about the order of operations. All right. Wow, number 13, here we go. Write the equation for the nth term and then find a to the 6th. Well, we know this is going down, right? So if we simplify this fraction, we would be able to get the ratio in this case. And I believe, let me get this a little closer. I even have my glasses on and I can't see it. Okay, it looks like it's 1/3. So we definitely want to use the fraction 1/3. So this is times 1/3 times 1/3 times 1/3. Ooh. All right. So a sub n is equal to a sub 1 times this r, right? The ratio, n minus 1. So a sub n is equal to 6,561 times 1/3 n minus 1. And there is our equation. Now to find a sub 6, we substitute in 6 minus 1. So you'll want to take 1/3 raised to the 5th power, take that times the 6,561, and I got 27. So hopefully you can get that to work out as well. Okay, what if we have it in a table? So I would like for you to tell me what the first term is, okay? So pause the video. You can tell me what a sub 1 is, and I want you to tell me what r is. A sub 1 and r. Please pause the video and answer that question right now. All right, now that you're back, a sub 1 is 11, and the common ratio, it looks like it is times 4. And you just want to check it out. Okay, So to write a sub n, we write our 11 and then times 4 to the n minus 1. Okay? So then to find our a sub 6, we would take 11 and raise 4 to the 5th power. Remember, that's going to be 6 minus 1, which is 5. So 4 to the 5th power times 11. And we'll get 11,264. All right, finally, we want to work from this. So I like to look at the, because we have the first, second, third, and fourth position. So let's just look at the range. Let's just look at the output values. Or you can make a table of values if you want to. I have 2, 6, 18, and 54. So let's find what my common ratio is. It looks like times 3. So a sub 1 is equal to 2. Common ratio is 3. So a sub n is equal to 2, 3 to the n minus 1. Okay, make sure that's a 1. Ooh, that's very sloppy. Sorry. Okay, so that a sub 6 then becomes 2 to the 3 raised to the 5th power. So a sub 6 is equal to 486. All right, that concludes chapter 6.